Hello students, this is Brock Skaggs. So I'm going to create this video demonstration creating the heatsink style parts you see before you. And so things you can notice about the part, and obviously the origin is placed on the very bottom surface, right on kind of that mid plane of the part. You can see in the isometric view. The call out for it. We've got a front to top view, a detail view showing some of the geometry associated with the individual fins that are raising above this plate. As far as material, we're going to go 6063 type O IPS unit system here. And so one of the things we're emphasizing here is the linear feature pattern. And so we've got this array of fins that's going in two directions there. And so what we'll do is create our first seed feature. We'll make that the bottom left one if you're looking at the top view. And then we'll use the linear feature pattern to create the remaining fins on this part. And it should make a very streamlined, very quick model for us to whip up here. And so with that being said, let's go ahead and hop right into SolidWorks and get going. And so I'll go to a new part document. Check my units as IPS, so I might as well go ahead and apply the material as well. So we'll just right click, go edit the material as usual. Go down to the aluminum alloy folder, and 6063 type O is right here. And so apply and close. And so if I go back to the PDF, we've got the isometric view here, so we'll keep that in mind. I'll just create the base feature as the plate. And so we'll go right back into SolidWorks here. I'm going to get on the top plane in order to make sure the isometric view looks correct. And so my base feature is going to be very simple. I'll just have the rectangular plate. And so it's just going to be a very simple sketch. We'll start off just a rectangle here in space using the rectangle tool. I'm going to select both the bottom edge of the rectangle there and the origin, and then I will apply the midpoint constraints or relation from the left-hand side here. The other thing I do know is that the plate is a square in cross-section, 3 1/8 inch along each edge. And so we'll go ahead and do that as well. I'll just hold Control down, select both of the line segments making up the edges, and hit equals. And then we can go through and dimension one side at 3.125 inches there in order to make the side length correct. And so that's a nice fully defined sketch. We'll go ahead and exit the sketch here. When I put it in the isometric view by hitting Control 7, you can see the way that square is oriented, and I've got the origin point right where I want it. And so we'll check the drawing. That's origin. If I zoom in on the isometric view, notice it's on the very bottom surface. So when I pull the extrusion, I want to pull it upward, what I believe is in the positive Y direction if you look at the SolidWorks triad here. As far as the depth that I'll be pulling it through, you can see right from the front view, 0.125, so 1/8 of an inch. And so we'll go straight into SolidWorks' Feature tab, and go to Extrude Boss and Base, select Sketch 1, and we'll go up the 1/8 inch, 0.125. And so that's our base feature. It looks like we're heading in the right direction. And so next we'll go to the drawing and look at these fins. And so the fins, they're not just a prismatic extrusion. They don't have the same cross-section all the way throughout. And so we've got this tapering effect, if you will. We've also got these rounds. And so one thing I'm going to do is use the loft tool. My profiles for the loft are just going to be two rectangles. One will be the larger rectangle, which is roughly a 3/8 wide by 1/8 inch tall rectangle if you're looking at the detail view here. And then notice from the note here, I didn't have a real great way to dimension it, so I just make a note here in the bottom part of my drawing right of the title block that the offset that I'm going to be using, the offset distance is 25 thousandths of an inch. And how high are the fins itself? Well, you can see from the front view that they are 1 inch here. And so the first thing I'll do is I'll just select the top face of my base feature to make my first sketch. And so I'll just select the face and then select the sketch command there. We'll get a rectangle going again. And here I'm just focusing in on the bottom bottom left-hand corner. And again, from the drawing, you can see right here is the 3/8 dimension for the width, and it's an 1/8 dimension tall. And so we'll get back into SolidWorks. Here's my height dimension at 3/8, and here's the width dimension at 0.375. What are the offsets here? To locate, say, this point, with respect to this point here. Should be able to grab that from the drawing. You can see the 1/8 inch offset from the vertical edge in the detail view, and an 1/8 inch offset from the bottom edge in the detail view as well. And so we'll just quickly apply those dimensions. And so with that, we've told the rectangle the width and the height. We've also located one of the points of the rectangles, and we know the orientation, and so that should fully define it for us, which it does. And so I'll just exit the sketch there. And so hitting Control-7 shortcuts me to the isometric view. Now this next sketch I want to be 1 inch above this surface. And so in order to do that, what I'm going to do is use a reference plane. And so I can create my own planes, of course, through the reference geometry. And so I'll go reference geometry plane. The reference I'm going to use will just be that top face. And you can see immediately it defaulted to a plane that is parallel to the front face but offset a certain distance, and this 1.00 value is what I'm looking for there. And so if I wanted to, I could play around with this whatever I felt like, put it in roughly pi units above if I wanted to, but for us we just want the 1 inch there. And so the reason I created this reference plane, you can see it as plane 1 in the tree, is so that I can now have another reference to sketch upon. So now this plane I can use to sketch, just like I used the top plane for the very base feature. And so I'll make a sketch on this plane 1. As far as what the sketch is going to be, well, it's just going to be a smaller rectangle, right? Because things tapered inward. The amount that it's tapered, you can see, is 0.025 inches per side. And so to do that, I'll make a very easy sketch, because I'm going to basically base this sketch off of the existing sketch geometry. And so what I'll do is I'll go up to Offset Entities, change my offset distance to 0.025, select the existing edge of the sketch rectangle from my previous sketch, and you can see the yellow preview showing here. Here it's going to try to push that rectangle outward to make it larger. Here I don't want to do that, I want to push it inward, and so I'll just hit reverse in order to achieve that. And so now by hitting the enter key and accepting it, I've got the correct offset that I need. Here it's showing 0.03 because I just have it rounding to 2 decimal places, but I can adjust the precision right over here by selecting the dimension and go to 0.25. So that looks like an acceptable sketch. So I'll just exit that sketch, Control-7 again, and now you can see the two sketches. I've got the top sketch here, which is sketch 3, and the bottom sketch here, which is sketch 2. So now the idea is just to loft between them. And so we'll use the lofted boss and base tool. And what this allows us to do is basically make a feature that's going to transition between these two set cross sections or profiles. And so right now it's waiting for me to select some profiles. And so I'll just select in this region of my first rectangle, kind of near that top right hand corner, and this similar region on the other profile. And the reason I picked those similar regions is because I want these connectors to follow the same vertices. Notice here, without getting into too much into the lofts, depending on where that second vertex is landing, I'm getting slightly different geometry there. And so here I want a nice linear translation between these, and so that's where I'm making sure to select the same points, if you will, or close to the same points. That way it picks up the same points for those connectors. As far as lofts, you obviously have a lot of different options over here. You can put in guide curves or centerline parameters to control this transition geometry, but for this specific example, it's just a very vanilla loft, which is a straight line transition between these two cross sections. So I'll just leave that as the default and go with it. And so here I'll just hide that plane, and you can see I'm getting close to my first seed feature. The only other thing I'm going to add to this is the round, and you can see from the drawing I've got rounds on these vertical edges with a radius of 25 thousandths. And so I'll hop back into SolidWorks. Here I'm going to use the feature fillet, so I'll just select it, manipulate the desired radius to 0.25, accept the constant size fillet, which is the default, and then I'll come in here and select the individual edges that I want. So those 4 edges look good, and I'll accept that and have the geometry as required. So far so good, except for now we need to basically copy this thing. We need to copy it in two directions. One direction will be in the X direction or along this edge. The other direction will be in the Z direction or along this edge. And so, of course, the way I'm going to do this is with linear pattern. You never would want to create this thing, the same sequence of events as far as the loft, fillet, loft, fillet, loft, fillet over and over again in order to create the remaining fins. You just create one and then you go to linear pattern. And so for linear pattern, you can do it in either a single direction or two directions here. And so we'll just do it as this being direction 1 and this being direction 2. And so as soon as I define my directions, I have the features and faces waiting for me to select, in this case, individual features to pattern. And so here I can select it from the graphics window, or you can also use the flyout tree here. I'll just hit the plus sign and I'll select the lofts as well as the fillets. And so at this point it's generating the preview. Notice there's a whole lot of them there. It's a 12 by 6 array, as you can see. But they're all smushed together, if you will. That's because of these offset distances aren't quite correct. And so I can also play around with the number of instances in each direction here. So I'll just leave that at 1. And so direction 1 was this horizontal direction. And so what is that offset? Well, you can see from the detail A, it's a 1/2 inch. And so I'll just replace this with 0.5. And at this point, I don't see anything because I have the instance count set to 1. And so here I'll increment that. And it looks like there are 6 rows on this, or 6 columns, whichever way you want to look at it, on the plate. Now for the other direction, the offset is just 1/4. So it makes sense that it's twice that many, so 12 to fill out the plate. So 6 by 12, that is what? 72 different fins now on this part. And so I'm now happy with the pattern, and I could accept that. And so this should be the default geometry I was looking for. So just to check real quick, I'll show the mass properties. Roughly 0.36 pounds is good. 0.40, and roughly negative 1.56 is the center mass coordinates. That looks correct. And so this was the model per the drawing we just made. And so everything's looking good. So we could stop the video here, but I do want to show one more thing in the linear pattern. And so I'll just go right click on the feature in the tree and go to edit feature. And I wanted to show the instances to skip. And so this can be useful on instances to skip. Basically what it allows you to do is create this pattern, but say we don't want all of these different fins. Say there's a couple we want to leave out. And so you just go down here to instances to skip. You can see little purple circles next to individual instances, and it'll also give you an ordered pair. This is instance 5,9 and 6,9 and so forth. And so what it allows you to do is just basically select individual instances. And so here I'll just pick a few at random to remove. And so now when I hit the linear pattern here, give it a second to regenerate, notice now I've got missing fins in my pattern. And so if you have select fins you wanted to remove from this overall pattern, that would be one very easy way to do it. And again, that's just right click, you would go in and you'd edit the instances to skip and basically populate this with the instances that you would want to omit. And so I'll just delete those out, let the pattern regenerate, and get back to the desired geometry there. And so that should be all for this video. Hopefully this helps you understanding the linear pattern portion of SolidWorks. Thank you for watching the video.